Now we're going to talk about rules of exponents. We've done a little bit of this in the beginning. Now we're just going to bring it on home and bring it all together, especially in this section. So the first thing we're going to do is we're going to evaluate each expression. Let's do it in blue. So 1/3 squared will be 1/3 times 1/3. So when we multiply fractions, we multiply the denominators and the numerators together. Denominator is 3 times 3 is 9. Numerator 1 times 1 is 1. So my result is 1/9. Next one, remember we did these? -1 squared. That means -1, the negatives on the outside, and I'm just multiplying the ones together. 1 times 1 is 1, and I still have the negative on the outside, so this will be -1. What about this guy? Since the whole thing is in his little nutshell, it's going to be -1 times -1, which is a +1. So when the nutshell comes, you write the negatives with it. And the next one says 5 times 2 to the third, which means 5 times 2 times 2 times 2. So we can do the exponents first using order of operations. 2 times 2 is 4, times 2 is 8, and 5 times 8 is 40. The next one is 1 to the 9th times 3 to the 1st. Well, 1 to the 9th is just 1, 2, right? And 3 to the 1st is just 3. So 1 times 1 times 1 times 1. All these ones multiply together will be 1 times 3 is 3. All right, rules for multiplying, which we've already been over a little bit. It says when you have the same base, you keep the base the same and add your exponents, because this really means MAs and NAs, so all together I have M plus N. In this case down here, I have 2 A's and then 4 A's multiplied by together for a total of 6. So if you think of it as that repeated multiplication, I think that you're going to be great. The power rules for exponents: when you raise a power to a power, you multiply your exponents, because this is really x squared times x squared times x squared times x squared for a total of 8x's. Now let's simplify each. 2 to the 4th times 2 to the 3rd is going to be 2 to the 7th. Why? Well, 2 to the 4th means this. 2 to the 3rd means that. So I get 2 to the 7th. Occasionally, you might have to multiply it out, but 2 to the 7th is too many 2's to multiply out, so you're going to use 2 to the 7th. Next one is x to the 4th times x to the 3rd. Really gives you, again, x to the 7th. Now what about these? So you start to panic, but you don't really, because this is the deal. 3st times 4sst. So we're going to multiply 3 times 4 like normal. So you're always going to multiply your coefficients. And you have a total of 3 s's. So s to the 3rd, and then you have a total of 2 t's. So think about it this way, you guys. S is raised the first. 1 plus 2 is 3. 1 plus 1 is 2. Now this one, we need to raise the power to a power, so we multiply our exponents. So it'll be x to the 12th, y to the 30th, and I'm done. I can't combine them because x and y are different. Now this next one, think about it this way. There we go. Let's look at it this way. Spread it out a little bit. First, multiply your coefficients like normal. And then I have 1x, 7x for a total of 8x's. I have 1y, 2y's for a total of 3y's. Okay, so here is the deal. What happens if I have a lot of stuff in the parentheses and then I'm raising it? That means I have to raise each one to that power, because the 2 has a power of 1 and the x has a power of 1. So 1 times 3 is 3. 1 times 3 is 3. I have to raise everything in that nutshell or in that parenthesis group to the power on the outside. The quotient rule says if I have a fraction or a division, I have to raise both the numerator and the denominator to that power. The quotient rule for exponents is this. If I have the same base on the top and the bottom, I just have to subtract my exponent and leave the base the same. So this is my example. 2 to the 4th over 2 to the 3rd. I always think of it as like this, you guys. I can't help myself. The 2's divide out to get 1, and I'm only left with 1, 2. And what about 0 exponents? A number to the 0 power is 1, as long as that number isn't 0. So what do I mean by that? Well, let's look at 5 to the 3rd over 5 to the 3rd. Well, using the quotient rule for exponents, I would subtract the exponents and get 5 to the 0, right? But 5 to the 3rd divided by itself is just 1. So 1 has to equal that number to the 0 power. Now we're going to do a whole bunch of different examples. So for 3a, we're going to remember that x is raised to the first power and so is y. So when you raise a power to a power, you multiply your exponents. So this will be x to the 4th, y to the 4th. Done. Next one, first we're going to have to square this and then multiply it by this dude. So remembering that each one of those guys is raised to the first power. We're going to raise a power to a power, so we're going to multiply our exponents. So it would be 3 squared s to the second t to the second times 4 s to the second t. And now we're in multiply mode. But 3 squared is really 9. S to the second t to the second 4 s to the second t. We're going to multiply the coefficients like normal, because they're just regular numbers. So it's going to be 36. S to the, I have 2 s's here, 2 s's here, so a total of 4. 2 t's there, another t, so I have t to the 3rd. Again, this t is raised to the first power. I'm going to add my exponents. C, what we're going to do, it's y over z. Both of these are raised to the first power, and I'm raising it to the 3rd, so I have to multiply my exponents. 3 times 1 is 3, 3 times 1 is 3, so I'm going to get y to the 3rd over z to the 3rd. And last but not least, d, they're divided. So I have 5 a's on top, 2 a's on the bottom, 2 will cancel, and I'm left with a to the 3rd. And you might be saying, why can't you just subtract your exponents and get that result? And you absolutely can. A little bit more intense here. This guy, look at him. I just divide 8 divided by 2 normally. 12 take away 5 is going to be a to the 7th. 2 take away 1 will give me b to the 1st. So you can write it as 4a to the 7th b. Either way you put it in, it'll take it. Let's take a look at this next one. So we get 21 s to the 1st t to the 5th, 3 s to the 1st t to the 0. So if I think about it, my s's are just going to divide out. 1 minus 1 is 0, but s to the 0 is 1. I'm going to normally just divide those. I get 7 t to the 5th, t to the 0. 5 take away 0 is 5, so this is going to be 7t to the 5th. The s's are gone. All right, this last one, we have to be extremely careful. So we have to raise the negative 8 to the 2nd power, the x to the 2nd power, and then y is going to be raised to the 6th, because 3 times 2 is 6. When you raise a power to a power, you multiply your exponents. And then I also have to raise that z to the 2nd power. Now, if you type this in MyMathLab like this, it'll say, although your answer is equivalent, we need it simplified more. And negative 8 squared is 64. I can't do anything else with that. Now you're able to do your MyMathLab lesson with this background. Good luck. Have fun.